Hi class, this is your assignment for the week of June 1st, and this is going to be your final assignment for the year. After this, I just want you to make up any missing assignments that you haven't gotten in already, and so this will be your final new assignment for the school year. All right, and for this assignment, you're going to be watching a video called Understanding Car Crashes, and I've given you a quiz form, and in the quiz form, I'll indicate times in the video where they discuss the information related to the question. So I might say time 4 minutes and 30 seconds and then give you a question. And the reason I wrote time 4 minutes and 30 seconds is because right around 4 minutes and 30 seconds into the video, that's where you should see the information that you'll need to answer that particular question. Okay? And I just want to give you a very brief introduction and then I'll let you get into watching the video. The video talks about momentum, which I think we've discussed before, which is simply the mass of an object times its velocity. And it also is discussing impulse. And an impulse is just a force applied to an object multiplied by the amount of time that force is applied. So if think of a student rolling across the floor in a chair with wheels on it, and then you walk up to that student and you push against them to slow them down. Let's say you push against them with 50 newtons worth of force and you slow them down for 4 seconds. Well, the impulse that you gave them would be 50 newtons times 4 seconds would be 200 uh, uh, newton second impulse. So the impulse is just the amount of force that is applied to an object multiplied by the amount of time that force is applied. And the reason that both of these things are important for car crashes is that it turns out that an impulse or in a car crash, the impulse that a person receives or a car receives is equal to the momentum of that object before the crash. Um, and what's particularly important in terms of keeping people safe is that you want to minimize the force that a person experiences. And if we simply divide both sides by time here in this equation, we get force equals the momentum before the crash divided by time. And this is really what uh, being safe in a car crash is all about. It's keeping the force as low as that a person experiences as low as possible. Right? But the force that a person experiences is going to be equal to the momentum that they had before they crashed. So their mass times velocity. So if they're traveling at a higher velocity, they're going to have a larger momentum. But the force that they experience is going to be whatever that momentum was before they crashed divided by the time it takes for them to slow down. And let me just put a couple of numbers on that to emphasize that. So let's just pretend we've got two people here in these two cars. They each have a mass of 100 kilograms, and they're both driving at 25 meters per second, which is about 55 miles an hour. So they both have a momentum of mass times velocity, 100 times 25, or 2,500. So they both have a momentum of 2,500, 2,500. Okay. And what we said just a moment ago was that the force that they experience when they crash is going to be the momentum before the crash divided by the time it takes them to stop. And so let's look at two separate crashes here. In the first crash, the passenger slams into isn't wearing a seatbelt. They slam into the windshield and they come to a stop very, very abruptly, very quickly. So just bam, and they stop. So that a hard, very rapid stop might take place in a very small period of time, well less than a second, maybe a thousandth of a second. And in this case, the force would be equal to the momentum before they crashed divided by the time it took for them to stop. In this case, a momentum of 2,500 divided by 1/1000th of a second would be a force of 2,500,000 newtons, so a very large force. In a second case, let's say a driver is wearing a seatbelt and there's perhaps an airbag in the car and the front of the car crumples and all of this stuff happening means that the person comes to a stop more gradually. And so this person in this car crash stopped in, they still stopped fairly quickly, but not nearly as quickly as the first passenger. And so in this case, they stop in 1/10 of a second, 0.1 seconds. And the force that the driver in this case would experience would be, well, they had the same momentum to begin with, 2,500, but now we're dividing it by 0.1 seconds. So the force that they experience is 25,000 newtons. So this is still a large force, but it is nowhere near as large as this force. And so in this case, the passenger might walk away, might have bruises from their seatbelt, might have some pain in their ribs and pain in their body, but they can probably walk away and survive a crash because they never experienced any forces greater than 25,000 newtons. Whereas if their body stops more rapidly, if they slam into something and come to a extremely abrupt stop, maybe stopping only in a thousandth of a second, they experience a much, much larger force. And this larger force will result in a lot of physical damage, and they might not survive the car crash. And so what you're going to see in this video is a lot of discussion about if you can create a situation where you get a longer stopping time, that means that the passenger experiences less force and therefore less injury. Okay, so the whole idea of it is a longer stopping time translates into less force. But physicists will quantify this, and they use that relationship that the momentum, which is mass times velocity, is equal to force times time. And they use that to quantify exactly how much force people experience in crashes under different circumstances. Let's say not wearing a seatbelt, utilizing any kind of technology such as airbags, versus if they do wear a seatbelt and there is an airbag involved, they can quantify the change in force that the passenger will experience. But it's all about reducing that force that the passenger experiences. Okay, so I just wanted to give you that quick heads up. Watch the video, answer the questions, and please email me with any questions. All right, thank you.